All right, now we're going to get into it. This video will kick off our discussion of 7.1, the estimation problem. So why we call it the estimation problem is because ultimately what we want to do is we want to estimate a population parameter. We look at 3 cases because these are the easiest ones for us to examine and they're the most common for us to examine. So we'll look at proportions, means, and standard deviations. To make this a little bit more interesting, I have here an actual real-life example. So this statement in pink in front of you here comes from Pew Research, specifically a March 5th, 2021 report where the experimenters sought to find out through public opinion how people feel about getting or planning on getting a COVID-19 vaccine, or they already have. So some context, of course. The first COVID-19 vaccine that was approved for public use and dissemination was in December of 2020, which means by this point in time that you're seeing this video, an increasing proportion of the population, not only in the US, but all over the world, has been vaccinated or is currently scheduled to get a vaccine of any of the varieties that are available now. There's at least 3 now in the US. So I just identify the important pieces of this statement in this Pew Research poll of 10,121 US adults. Important piece there. 69% of them said they will get a COVID-19 vaccine or they already have. So 69%, by the way, is, that we're talking about in this specific study, right? So the people who responded, 69% of those people are the ones who said this. And the margin of error here is plus or minus 1.6%. So there's a lot going on here, a lot of figures. How do we make sense of this? And that's what we seek to do with the confidence interval construction. Okay, so first off, some definitions. So what is a confidence interval? What we actually have here in this statement is an example of a confidence interval, but it's stated in an interesting way. It's stated in terms of some estimate and some margin of error. So our background here, our context, is we want to estimate some population parameter. And generically, we'll call that parameter theta. This is the Greek letter theta. It could stand for proportion P. Could stand for mean mu, also a Greek letter. Or it could stand for standard deviation sigma. Also a Greek letter. So all 3 of these are examples of population parameters that we might want to estimate using a confidence interval. So the confidence interval itself is a range of values for which the probability that the interval contains theta is some high threshold. So importantly here, so imagine that we have this proportion that we're looking for. So we seek the proportion P, which is the number of US adults who will get vaccinated at some point out of the total population, which is the number of US adults. So symbolically, this is a population proportion which we denote as P, and the number of people in our interest group is X, and the number of people in our population is N. So actually, let me call that capital X and capital N. The reason why we do this is because we have some estimate. We have a point estimate. So our point estimate is the sample statistic that we draw that tells us, or it helps us estimate the population parameter. And the confidence interval is tied to this point estimate. So it's the number of people in our sample who say they will get vaccinated or already have, divided by the sample size. So this is our lowercase x and our lowercase n. So the number of people in our subgroup of interest in the sample divided by the number of the sample size. So in other words, if our US population is yay big, right? The number of adults is somewhere in the order of like 200 million people. That's our N. And in our interest group, right, the number of people who say they will get vaccinated, that's our X, right? So according to, whatever estimate it could be something along the lines of, 140 million. And that is X. Okay? So that proportion, right, maybe that's the same as the proportion of people in our sample, right? So how many people are in our sample here? We said there were 10,121. That's our sample size. And of those, right, how many people responded that they were going to get vaccinated or they already have been vaccinated? And that's little case x. And we can find that out directly from the study. In fact, I have in front of me the actual results. So, and you can do this yourself too. You can find out what must x be, because ultimately this is a formula right here. And to find out what the exact number of people, we can multiply the sample proportion by the sample size. So the exact number of people is our 69% expressed as a decimal times the number of people in our sample. And if you calculate that, always round to a whole number if you can. But you can also keep it precise. So 6,983.49 people, or approximately, if we want to, not undercount, that's 6,984 people, right? 6,984 people. What we're hoping is that the relative proportions, right, that they're similar, because we know this one. We want to find this. And that's what our confidence interval will help us do. Okay? So we have now our idea. So we have some let's call this the parameter space, or the total range of values that our parameter could take on. Since it's a proportion, we can go all the way from 0 to 1, 0 meaning absolutely no people want to get vaccinated, and 1 meaning all people want to get vaccinated. And we're estimating P using our sample proportion, P hat, which is 0.69, and we're given a margin of error. The margin of error tells us how wide our confidence interval is. Namely, we said, let me go back. The margin of error is give or take 1.6%. So we're going to add the margin of error, and we're going to subtract the margin of error, which, quick calculation, right? So we have 0.69 plus 0.016, or 0.69 minus 0.016, because we convert everything to decimal numbers, right? Which means we find that this value, the lower value, is going to be 0.674, and the higher value is going to be 0.706. So this is our range of values that make up our confidence interval. Specifically, we could write that confidence interval as, in interval notation, 0.674, comma, 0.706. Or we understand we can write this also in percentages, but we will prefer not to. So we range from 67.4% to 70.6%, and our sample proportion, 69%, is squarely in the middle. Or we can alternatively write it as our population proportion lies somewhere between these values. So whatever our population proportion is, right? Let's say it's actually just a smidge higher, right? Let's suppose that our population proportion is actually 0.70 on the dot. This is obviously not something that we know for sure, right? But it's possible that this is true. And so then we would say, oh yes, then it lands in our confidence interval. We did a good job. So in the next video, we'll explore what it means for a confidence interval to have been successful, and how we guarantee that, and what's the acceptable risk that we take on in the construction of a confidence interval.